OMIS 351, Business Intelligence and Data Analytics. Unit 6. This is a big deal. Information is the oil of the 21st century, and analytics is the combustion engine. That's quite a quote. Here's another one. Data. We are awash in data, and as business professionals, we need to make the most sense of it to help our organizations be competitive, gain strategic advantage, and stay profitable. How significant? Facebook, Google, your car engine, your toaster is generating data. All the transactional data going on, the clickstream data going on when we browse the World Wide Web and the internet. Absolutely amazing. Is one of the biggest opportunities for people of your age. You got to know how to deal with data. You need to watch the video on the introduction to Microsoft Access. A relational database will help you begin to be able to get in control of your data, to answer questions about your business. That is business intelligence, being able to answer questions about your business. And when you have this much data moving around, it becomes all the more important. You cannot be left on the sidelines. You have to be in control of your data. You have to have a business brain. You have to know about your business. Business intelligence is mostly what happened in the past and what's happening in the present. And data analytics is mostly about what's happening in the future. Predictive analytics. There are definitely blurred lines with those definitions, but that's kind of how it is evolving in the business community. In the case of big data, 3 V's. There's a lot of it. Volume, it comes at us quickly, velocity, and it comes from all sorts of sources, variety. In addition to the 3 V's, value, who cares if it's not worth anything to our company, and veracity. We talk about fake news and other things like this. Veracity means, is it good data? Is it true? Is it useful? As you understand and deal with the massive influx of data that our economy is generating, you have so many opportunities. A very basic one was signed into law over a decade ago. And the idea was to get everyone to have an electronic health record by 2014. I laugh because we're way past 2014, and I went to a medical specialist the other day who was affiliated with my primary care physician. And you know what happened. They handed me a clipboard and a pen with 4 pages of stuff to fill out, including my name and address. Come on, folks. We're not doing well with electronic medical records. And more importantly than the inconvenience of me having to fill out things on a clipboard would be inaccuracies if you gave someone a medication they were allergic to, and also the excess cost of these inefficient processes. There are opportunities in data for you wherever you go. This is a big one. So what can you do? Again, watch the Access video. You're going to have assignments on that. VC6, Virtual Case 6, you have to do a database by yourself. It will be different than every other student in the class. Then if you're a manager, these data sources have to be centrally accessible. An easy way there is to have it on a web page where everybody can get to it through a web browser. From a process standpoint, where is the information coming from? And let's only enter it one time. We don't want contradictory information. We don't want bad information. We don't want it becoming bad data. And if it's on spreadsheets, you saw how to import that into Access. Spreadsheets do not consolidate well. We can't keep corporate information all on spreadsheets anymore. It just doesn't work when it needs to be combined. Seen some of these definitions before. Data is just the characters and the fields put together, but information is data with meaning and context. Database collects that all. Relational database ties tables together. And more powerful than information is a query. So I always say data is like the characters C, H, U, C, and K. They're just characters on a keyboard. It becomes information when you say this is your professor's first name, Chuck. If we have a bunch of professors in a table and a bunch of tables, we might get a database, relational database. But then if you said which professors have gotten the highest student ratings over the last 5 years, that's a query. A query is fancy for a question. An ad hoc query is an as-needed question. So if you ask that question about the professor, the answer to that query becomes more powerful than information. So the most valuable thing is business intelligence, followed by a query, followed by information, and at the least is data. Data mining is when we let the computers in an automated way ask many questions. The example I just gave you here about which professor has the highest student ratings, that was a question I came up with as a human. Sometimes as humans we're limited and we can't think of all the good questions. And so we say to the computer, try and ask every possible question that someone could ask about this data and give us the results that are interesting. That's powerful. We've had things learned like the sales of beer and diapers are correlated, come from data mining exercises. That's a true story. It sounds like a joke. If you've ever cared for small children, it won't surprise you that beer sales and diaper sales are correlated, meaning they move up or down together. If someone is buying a lot of diapers, they're probably, or in many cases, buying a lot of beer. That's correlation. No one thought to ask that question, but they learned that, and then they actually moved beer closer to diapers in the store to encourage even more sales. But that's a famous, and again, it's not a joke, a famous data mining story. So here's kind of the conclusion. Corporate information is stored in a database so that it can be queried and or mined to provide the highest level goal, the most powerful business intelligence. We want to have a business brain. So here's a picture and we say, let's order these things from smallest to largest, these elements of a database. They're not in the correct order. Character is the smallest, but a bunch of characters make up a field. So I'm going to move that. That's the next biggest. A field being something like first name. If you put a bunch of fields together, first name, last name, office, a bunch of fields make up a record. A bunch of records, Chuck Downing, Dr. Orend, other professors, make up a file called the professor file, or a table. We've called that a table in Access. Let's make that a table. Table or file being the same thing. And a bunch of tables make up a database. So there's the new order from smallest to largest. File processing is, unfortunately, still happens 33% of the cases. Everything stored in most instances on a spreadsheet. Separate spreadsheets are the files. So if we have sales, production, and marketing storing their own stuff, look at these spreadsheets. Every one of them has product name. We see this all the time where they might call it something a little different or they might spell it differently. And then computers are so literal. If you call something a pointer and you call something a laser, they call it laser, they call it pointer, they call it classroom instructional tool. The computer thinks you have 3 different products, so you really can't combine I mean, that adds to the problem. So you have a lot of problems. You have inconsistency in, say, naming. We have a lot of wasted space. We have no good integration, set format, lots of problems. It's easier for the employees. They love spreadsheets. They just get to enter it, but that creates all these problems. So the solution is a database management system, which Access is one of. One integrated repository, and we get to make reports. This is pronounced SQL, SQL or SQL. That is the standard language to create queries. And now all these departments feed into the database management system, and we just, if somebody changes the name of the product or even misspells it, everybody at least sees the same thing. So that's very valuable. Your components, data definition, and administration are in something called the data dictionary. That would be like the design view of a table where you define the type of the field. This is currency, this is a date. That's what data definition means. Application generation is something like a form that we made in Access in VC4. And data manipulation is, entering, editing, changing data. Those are the main components. There's another look. Big relational databases are Oracle, Access, Sybase. And you can take a look at that. That's what we've been doing. And then a simple database, you have one table. Let's say we tried to do this on a spreadsheet. We'd have all these customers, and then they bought stocks. So we made a second spreadsheet, but now look what we're doing. We're repeating the customer name. And then let's say he changes his name or he moves to a different state. Now we got to change all these rows. This is a terrible way to do it. The correct way is the relational database. We have one table for customers, and then we tie it through the relationships in Access. In our case, we tie it to the other table. We use the customer ID here. Then if he changes his name or moves to a new address, we only have to change it one time. So this is stuff you've seen in Access anyhow. Relational database, structured query language, by far the most popular database language for creating queries. Here's an example of SQL. If you wanted to find all your employees, we've seen this in Access, all your employees whose salary is greater than $2,000, select name salary from employees where salary is greater than $2,000. If you go into a query in Access, there is a design view where we make the query. There is a data sheet view, which we called the answer to the query. And there's a third view called a SQL view. If you go into that in some of your Access, like for VC5, some of those queries, and take a look at it, you'll see code that looks like this behind it, so you know how the query was made. It's very powerful to know SQL. And again, a data dictionary is data about data. So what happens here is, this is the design view of a table. This is a currency field. This is a text field. This is a date field. So it tells us what this data is. It's data about data. Entity relationship diagram, you need to know that acronym and term, ERD. The way for you to think of it as a business manager, it's the relationship screen in Microsoft Access. So it's how the tables are tied together. We've talked about data mining and OLAP. OLAP, online analytical processing, sometimes those things are organized into data cubes. And basically, it's queries. And data mining is where the computer does the questioning, tries to ask every possible question very quickly. And data warehousing is a big database, gigantic corporate database. It is batch updated, meaning not in real time. We collect our information and then send it to the data warehouse. And it is cleaned, meaning if somebody spelled my name wrong or a customer's name wrong, we try and correct that before we put it into the data warehouse. And that's easier said than done, but that's what happens. This is what I just said. We've said a couple times on data mining. Here's warehouses in Mart. Here's the official definition. Enormous amount, batch updated, so we can ask questions of it. And a data mart is a subset of a data warehouse. So you might have, just for my department, we have our own little data mart. A subset means it's a part of, a component of, smaller than the whole data warehouse. So there's how that works. TPS means transactional processing systems. They're generating data. Marketing has its mart. Engineering has a mart. And it all works together. Okay, we've talked a lot about databases and access. But business intelligence, it's okay to use spreadsheets. When we say they don't combine well, which is true, and they don't integrate well, which is true, that's true about spreadsheets. It does not mean they're not useful. The most popular decision support system engine in the world today is Microsoft Excel. So that's important. It's still very useful. If all your data can be contained on one spreadsheet, you absolutely want to use Excel. You use Access when you need to combine multiple sources, multiple spreadsheets, and aggregate them. Then you got to use the relationship capability in Access. 3 models: sensitivity, how does one small change, people just, this is the what if stuff. And we did goal seeking in the millionaire example of the Excel intro video. If you want to see the Excel intro video, look way back into the virtual case description. There's a link to it so you can see that example. But that's goal seeking. What if I change this number? What if I hire more employees? And the spreadsheets, of course, we know how that works. The answer just comes to us when we change one or more cells to check sensitivity, what if, and goal seeking. So spreadsheets are gigantic. And pivot tables, there is a video on pivot tables in VC2. That's very important. So if all of your data is in one spreadsheet, your answers are almost always going to be more easily obtained using a pivot table. And it's very easy. Again, the video is probably better than these 3 simple steps, but it works really well. And so pivot tables also a very powerful tool to get business intelligence, to do data analytics. In fact, in VC2, that was a data analytics virtual case, and we used pivot tables. Here's another acronym. We have a lot of them. EIS, Executive Information System. Specialized DSS for senior management. So it might have sensitive data, employee salaries or something that a middle manager wouldn't have access to. Executives get sensitive data, and executives also love big picture. Oftentimes this will be called a dashboard, and I have a picture on the next slide. But they want consolidation. Executives are very busy. They need to see it quickly. If they want to drill down and get more detail, it has to have that capability. And slice and dice and drill down, to me, are very similar. So here's an example of a dashboard. So the executive's eyes might just go to this red, what's wrong here? What's wrong here? The idea is to get the executive's attention to areas that need managerial decision making as quickly as possible. So that's an executive information system. And lastly, artificial intelligence. Obviously, this is a huge topic that we could spend a lot of time on. We've seen big successes in artificial intelligence. The Jeopardy champion was beaten by a computer. Garry Kasparov, the grandmaster, Russian chess grandmaster, was beaten by a computer. So this is happening, and it will continue to advance. We're trying to simulate human intelligence. I personally don't think you have to worry about computers taking over the world or something in our lifetimes. Ultimately, we still program them, but we're getting better and better at programming them how to learn on their own So it is very impressive, some of the things we see in artificial intelligence. For now, though, the most easily the most common artificial intelligence in business and most used is something called an expert system. And from a very high level, an expert system is a database lookup. So we codify the knowledge of human experts into a computer so that instead of paying these human experts large amounts of money, we can just ask a computer because we've essentially saved their knowledge into a database. Great examples of this are loan approval. Um, that's the next slide, I believe, where if you have a senior loan officer, that person makes a lot of money, but really they're asking some fairly standard questions. I personally believe that primary care physicians will be entirely outsourced to expert systems probably in your lifetimes. We're seeing this a little bit at Walgreens and CVS and other places where we're trying to automate some of the things. Think if you go into your primary care physician, they take your temperature, they take your blood pressure, your weight, they take some vitals, and if it's something basic, they say, here's antibiotics, or get rest, drink lots of fluid, or whatever it is. I'm not disrespecting these people; they're very smart people, but they're asking standard questions. We could codify a lot of their knowledge into a database. And then what happens with your primary care doctor if you have something really weird, right? If you have something really weird, your primary care doctor sends you to a specialist anyhow. So if the computer looked in its database and said, I have no idea, I've never seen these things before, it would be the same result. So the specialists will still be around for a long time, I believe. Neural networks, trying to imitate how the human brain works, and intelligent agents, specific tasks for us. These are real and people are working on them. They're just not as advanced. These are being used, expert systems are being used in business today. Here's an example. They took their senior loan officers and they put it into an expert system and they deployed it to many offices. A lot of money saved. You think of the other thing that this does for you, it takes away your vulnerability as a business of being accused of bias, right? Because we didn't give you a loan and you say, well, that's because you don't like me because of this, this, and this. You do not want that in your business. And if you have an expert system, you say, that's not true. The computer treats everyone exactly the same based on these criteria that we programmed in. So you do have some defense there for things like that. So all of this stuff is about data and business intelligence and organizational intelligence, knowing what has happened in the past, what is happening now, and hoping to predict what's going to happen in the future. And you do that in your organizations today using data. Good luck. That's the PowerPoint part of Unit 6.